Find the third term in the expansion, 5x minus 2y, all raised to the 6th power. Now, we're going to relate this to Pascal's triangle as a quicker way to achieve the answer. Pascal's triangle creates this array of numbers in a triangular form where the number are formed by the sum of the two numbers directly above it. And we always start with a 1. So I need to go out to row 6 as I demonstrate this. Now the first number we start with is a 1, but that never actually constitutes the first row. And actually, you know what? I'm going to take this and I want to move this to the middle where I have a little more space. So it starts with 1. Now, this is really going to be row 1. Now, how do I come up with the next rows? I always start each row with a 1 and I always end each row with a 1. The numbers in the middle will be combined from the sum of the numbers directly above it, as I just stated. So a 1 and a 1. Now, 1 plus 1 is 2. This is going to be row 2. Okay, I always start with 1 and end with a 1. 1 plus 2 is 3. 2 plus 1 is 3. I start with a 1 and end with a 1. I'm just going to abbreviate. This is row 3. Now I need to go out to row 6 for this particular problem. Now you could write this down quickly, or as soon as you get your test, when you get your AP exam, likely you'll have one question like this on your test. And we'll practice this in the next 6 to 8 weeks. But once you have that triangle down, it will work as we try to expand any of these different binomial expressions. Okay, let's go on to row 4. I start with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1. This is row 4. I start with a 1. 1 plus 4 is 5. 4 plus 6 is 10. We have 10, 5, and end with a 1. Why am I going out to 6? Right here. This one never counts, or you could count this as row 0 if you want to do that, but this never actually factors into when we're deciding how many specific rows do I go. So I need to go up to 6. There's 1, 2, 3, 4, 5, and 1 left. I have 1, 6, 15, 20, 15, 6, and 1. Okay, so we have the structure that looks like a triangle. It always starts with 1 at the top, and then each sequential row is formed by adding the two numbers directly above it, as we could see. So 1 and 1 is 2, 1 and 2 is 3, 2 and 1 is 3. You guys get the idea of that. The Pascal's triangle is closely related to expanding the binomial expressions, and we're going to see how this helps us to come up with a quick way of identifying the coefficients. So this is what I have, and now this is going to be, if I look here, this is going to be what I'm going to call my first one, and this is going to be what I call my second. So I have A, I'm going to call 5x, and B, I'm going to refer to as negative 2y. So notice that we need to go out to 6. So I'm going to start here, and I have 1, I'm leaving a space, 6, 15, 20, 15, 6, and 1. Those are your coefficients. Now I'm going to start with A, and it's going to be A to the 6th, A to the 5th, A to the 4th, A to the 3rd, to the 2nd, to the 1st, and to the 0. And now if I have a different one, I don't know if this one works, but we'll see. And now we're going to go backwards. So this is going to be B to the 6th, B to the 5th, B to the 4th, B to the 3rd. I meant to put a B here instead. I said it, but didn't write it down correctly. To the 2nd, to the 1st, and to the 0. How is this helping us? We're asked to find the third term. This is the 1st, the 2nd, and here is the 3rd. So we're not asked to do this to expand this entire thing. We're just asked to find a specific term as we expand this binomial expression. So it's 15, and I'm going to leave a parenthesis with the 4. Now what is A? It's 5 to the x. And then it's B to the 2nd. So B to the 2nd, what is B? It's negative 2y. Okay, so I have here, if I move this up, I have 15, and then I have to share this, if you remember this rule about exponents. So it's going to be 5 to the 4th and x to the 4th, and negative 2 squared and y squared. So on my calculator, I'm going to grab a calculator, and I'm going to figure out what is 15 times 5 to the 4th times negative 2 squared. So that's the first thing I'm going to do here. I'm going to grab that. 15 times 5 to the 4th times negative 2. Make sure you're putting it in parentheses or it will be wrong. And you could, oops, sorry, this is wrong because I didn't put the square on the outside. That is why it's wrong. Does everybody see how I did not put on the outside? I should have done that for both of them. Let me go back and demonstrate the correct way to plug this in. So it's 5 raised to the 4th, and this is negative 2 squared. And now you can see I have the correct answer. So that's very important. Okay, 37,500. Now let's look at the variables. We have x to the 4th and y to the 2nd. I'm going to press pause and we're going to practice another problem like this. Find the 4th term in the expansion 3x plus 4y raised to the 5th power. So this tells you what row in Pascal's triangle. So I want to explain once again, even though it'll be much simpler, and for the final example, similar to this question, I'll just go back to this picture. But I want to explain once again, how do I start this? This is, if you want to think of it as row 0. Then we have, this is row 1. Again, you're not having to recreate this every single time. That's row 2. This is row 3. Oops. 4, 6, 4, 1. This is row 4. 1, 5, 10, 10, 5, and 1. Why am I going on to row 5? Because I'm asked to find the 4th term, and this quantity, this binomial is raised to the 5th power. And you can see that when I come here, I get the exact same thing, 1, 5, 10, 10, 5, and 1. So those help me with my coefficients. So 1, 5, 10, 10, 5, and 1. And now I'm going to say that I'm going to come off to the side. My a is 3 to the x, and my b is 4y. Notice that this time my b value is positive. All right, let's get started here. Okay, so I'm going to say, counting down here, so it goes with the highest excellence. So this is going to be 4, 3, 2, 1, and 0. And then I'm going to go backwards here. I thought I had a different, there it is. And then I'm going to start with my b. b to the 5, b4, b3, b2, oh my goodness, b2, b1, and b0. Now let's go to the 4th term. So the 4th term, 1, 2, 3, 4. This is what I'm looking for. So 10 times a squared times b to the 3rd. What is a? A is 3x. What is b? B is 4y. So I have 3 squared times x squared, 4 to the 3rd times y to the 3rd. Okay, so on my calculator, I'm going to take 10 times 3 squared times 4 to the 3rd, and then I have an x squared and a y to the 3rd behind it. All right, here we go. So I have 10 times 3 squared and 4 raised to the 3rd power. We end up with 5,760. 5,760 x squared y to the 3rd. Okay, the 3rd example, I want you to do on your own. Press pause once you've wrote down the problem, and then come back to the video to see if you were able to get the correct answer. 2nd term in the expansion of the following. Okay, but notice this is to the 7, so that's like row 0, and this is going to be row 1. 1, 2, 1, 1, 3, let's see here. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10. There's 5, 10, 10, 5, and 1. 1, 6, 15, 20, 15, 6, and 1. Oh, hold on, this is row 1, 2, 3, 4, 5, 6. This is row 6, and I need to go to row 7. 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so let's write this out. 1, 7, 21. Now, here's where, if you're starting to really catch on to this, well, we can start to be lazy. Efficient is what I like to call it. We want to find the 2nd term. So I know this is the 2nd term, right? And so do I really need to write all this out? I don't think it's really necessary. I know it's going to be 7. Now what I need to think about is, how do we do these other problems? So remember when I counted, we would say that in this problem, a is equal to 3x, b is equal to negative 2y. And so we'd start with a to the 7th, and then it'd be a to the 6th, right? All the way down to a to the 0. So my 2nd term is going to be a to the 6th. Now, when I'd go backwards, I'd end up with this being b to the 0. So if this is b to the 0, this would be b to the first. What you should have noticed if I go back and show you is that these exponents always add up to 7. Let me show you. In this case, they're going to add up to 5. So watch. 5 and 0 is 5. 4 and 1 is 5. 3 and 2 is 5. 2 and 3, 5. 5 and 5. Let's see if we can look back here. So this problem was to the 6th. Watch. 6, add together 6, add together 6, add together 6. So when I'm doing this last example right now, I know, let me find where it is, here it is. I know what they need to add together to give us 7, and so I'm feeling confident this is 6 and 1, and it is the second term. So this is just a faster way. If you feel comfortable writing all of these coefficients out, and then marking it a to the 7th, a to the 6th, a to the 5th, and then going back and reversing with the b's in reverse order, feel free to do that, but this is a quicker way that you can do this. Okay, there's my a, and here's my b. Now what is a? It's 3x, and what is b? It's negative 2y. So I have 7, 3 to the 6th, x to the 6th, and negative 2 to the 1st, and y to the 1st. So on my calculator, I'm going to do right now the coefficient. I'll make sure you guys can see this. And so I have 7 times 3 to the 6th, and then we're going to go times negative 2 to the 1st. And I end up with negative 10,206. Negative 10,206, x to the 6th, y to the 1.